We're live now.
Okay.
Sessions prior to today, we have a very insightful webinar lined up for you. Today, we are going to focus on how we as teachers and parents can tackle the phobia of math and build a mathematical bent of mind in our students. We have with us a very young and enthusiastic facilitator for today's session, Mr. Mohammed C. Ajmal. Hi, Ajmal. Welcome to the session.
Hi.
So good to have you with us
Yeah,
today.
thanks, Karthik. Yeah,
A quick
thanks, Karthik.
introduction. Ajmal is an alumnus of IIT Madras and he's currently working as a system on chip design engineer at Intel. He is also the founder of Elan Learning and is very passionate about education content creation. Today, as the topic suggests, Ajmal is going to talk about, of course, how math phobia could be removed, but he'll also share an engineer's perspective on how mathematics as a discipline is being delivered in our schools and what changes he feels should be made in the curriculum to make math learning more effective. Over to you, Ajmal, and all of us are looking forward to a brilliant session.
Thanks a lot, Karthik. Uh, and thanks all people for joining in this for webinar. Okay. Uh, so about me, as Karthik mentioned, uh, I'm an engineer at Intel. I do chip design or system on chip design to be precise, and so many of you might be thinking why I'm talking here. I'm basically an engineer. I work on chips, electronics, and why am I talking on math education? Okay. First of all, I'm not an expert on education, I would say. But what I've done over the years, uh, I have, other than Intel, I have my own startup called Elan Learning Labs, where we focus on STEM education. Plus, last 10 years, for last 10 years, yeah, from the day I joined in IIT, I've been teaching mathematics to, especially to kids, especially to high school, higher secondary school students. Okay, so I have around 10 years of mathematics teaching and just sharing certain insights I have, or sharing some thoughts I have with all of you. And after that, we'll open it to the discussions. Okay. I grew up hating maths, actually, hating maths and physics both, because I couldn't find any joy in doing any math. It was not like I was not good at math, but I couldn't find anything satisfactory in doing math at school. I used to get good marks, but especially in my 8th standard to 10th standard, and even in physics, I used to find the physics concepts very absurd and very weird. I couldn't make sense out of most of the theories which were taught in school, especially certain things related to electricity, electronics, etc. But apparently, I became an electronics engineer. That's another side of the story. But when I came into 11th and 12th, I found physics and maths to be my most beloved subjects. Reason being, I couldn't, whatever I was missing, the reason, the logic, the correlation I was missing in my high school, I couldn't find it in higher classes. And then I became a kind of an expert in both. Okay, and even right now I write scripts, algorithms. There's a lot of complex problem solving involving in my job, which I owe a lot to the mathematics training or mathematics concepts I had at my school and in IIT. Okay, so Karthik, are you sharing the screen, or I can share the screen, right? Yeah. So what do I do? I work at Intel, as I told. Plus, I have my own startup called Elan Learning Labs. Plus, I run a classroom uh, in YouTube, where I don't find time nowadays to post any videos I have. It's called Ajmal's Classroom. I post physics and math videos for school students. They're mostly in Malayalam, in my mother tongue, since many content is already available in English. So I'll start, since this is about maths, we always have to start with problems, right? So I'll start with a couple of problems, as in any math class, actually. So I know that there will be math teachers here as well as some uh, people from other background too. Okay, so this is something called Monty Hall problem. Okay, it's a very famous math problem. People will know for sure about this problem who are our math teachers for sure, right? So if you're on a game show, this is a very famous problem. So you're on a game show and being asked to choose between three doors. Okay, behind each door there is either a car or a goat. So there are three doors, and behind two of them there are goats, and behind one of them there is a car, and you can choose a door. So whatever is behind that door is yours. It's purely based on luck. You can choose any. There is no clue, there is nothing else. You can just choose one door. Okay, I just want you to listen carefully to me. The host, who is known as a Monty Hall, picks one of the other doors. So once you choose, let's say there is 1 2 3 and you choose 3, and the host opens either 1 or 2 and show you that there is a goat behind that. So now there is only two doors which are not open, the one which you chose and the one which has not been opened by the host, and behind the other, you know that it's a goat. So Monty will always reveal a goat. Out of the two doors he will always reveal a goat. Monty then asks whether you would like to switch your choice of door to the other remaining door. So you have chose, let's say, number 3, and do you want to switch to the other door which is not open based on the goat he has shown. So assuming you prefer having car more than having a door, do you choose to switch or not to switch? Okay, that's the question. So if anyone wants to answer, they can answer through the chats. I'm just looking at that. Okay, so so this is a scenario, right? So you have chosen either 1 or 2. So let's assume you have chosen 1. Okay, then you have 2 and 3. The Monty, he opened 3 and showed that there is a goat behind that. Now the car is behind either 1 or 2. Will you stick with 1, or is there any advantage in switching? Okay, uh, okay, so people are telling I'll switch, not to switch, I don't want to switch. So why do you don't want to switch? Probably because you don't find, yeah, anyway it's the same probability, are you thinking, right? Okay, so actually this is the probability. So behind the door 1, uh, if you see that if you switch, if the result, if you switch, there is a higher chance that you will get the car. So if you see here, I'm not explaining a lot of math problems here. I'll uh, leave it to you. You can Google it and find out, and it's not the purpose of this lecture to explain it, right? So it says that if you switch, there is a chance that there is a higher chance that you will hit the car. You will have a 2/3 chance. If you don't switch, your chance is just 1/3. Okay, so I'm sure that it will baffle some of you. Okay, let it be, and that's the beauty of mathematics. Uh, you can go ahead and look at that. Okay, now how do you calculate 1 plus 2 plus 3 plus 4 etc up to 100? What is the value of 1 plus 2 plus 3 plus 4 plus etc up to 100? Okay, so this question was asked in a medieval century math class by a teacher who was irritated by his students, and uh, this the teacher gave this question because it will take a lot of time to calculate, to add between 1 plus 2 plus 3 plus 4 plus etc up to 100, right? And someone called Carl Frederick Goss, okay, he did it in a few seconds. What he did was he found some patterns, like 1 plus 100 is 101, 2 plus 100 99 is 101, and he found a pattern in these numbers, and actually he found the answer very quickly. Okay, this is some other story that many of us will know. And this one is yeah, many of you are already answering in the chat. What are the odds that two of you have the same birthday, right? So right now I see that more than 400 people are watching this online, and assume that I take uh, two of you, only, right? I choose two of you. What are the odds that two of you have the same birthday? It's very it's the chance is very less, right? two of you having same birthday, right? Because two of you, there are 365 days, and two of you having same birthday is very less. Now if I choose a team of 20 among 400 of you or 500 of you, what are the chances that you have the same birthday, two of you have same birthday? Actually it shoots up to more than 50%. If I choose a group of 75 of you, uh, even though if you think that there are 365 days, there are only 75 of us, the chance that two of you among these 75 have shares the same birthday is 99.99%. So there are certain elements of math, right, that excites us. So I'm not going to explain all these problems and all. So what I just wanted to indicate with these problems is that math is inherently interesting. There is a relevance to math, and math should be always interesting to us. But we find that every now and then our kids, or the kids in our classrooms, they complain that math is I hate mathematics, right? I uh, I don't like mathematics. Mathematics is so stupid that I don't know what I'm doing. What is the use of doing trigonometry or geometry or circles, etc., etc., and so on, right? I'll open that talk with a question. So we know that cricket is a very popular sport in our country, right? Cricket is a very popular sport, and people make a lot of fortune. Especially professional cricketers are one of the most well paid among the country, right? So based on that, what if learning cricket was mandatory in schools? What if learning cricket was mandatory in schools? Imagine a scenario in your schools learning cricket was mandatory. So in the pre-primary school, we learn about there are different types of ball. There is kookaburra ball, there is this ball, that ball, this is the shape of the bat, and these are the different types and shapes. These are the length and width of the cricket field, right? And these are the like these are the width of the pitch, these are types of pitch. Then when you get to the primary school, then the teacher will teach you how to hit a ball, right? How to hit a ball, how to drive a ball, how to pull a ball, how to swing a ball, right? And in secondary school you will learn about field placements, where to place fielders, what are the captaincy techniques, etc. I'm sure that in such a scenario, if we learn cricket like that, we don't find instead of finding cricket fields or bats or balls or actual playing in the school, if we learn it through textbooks, if we learn it through like all the theories we have before, and if you put a mandate that to become a professional cricket player you have to go through all this stuff, right? Then cricket will be very boring for sure, right? Just like many people find mathematics boring, I'm very sure that our students will find cricket also boring, or football or painting as or music as such, if we put that in our schools as a mandatory subject, going through all these steps, right? And assume that you have to learn music and you have to know that what each symbol means, right? What each symbol means, then only you're allowed to sing. Think of such a scenario, it doesn't make sense to me, and it will not make sense to most of you, right? So that's a perfect example of how boring a beautiful game like cricket will be, right? So similarly, everyone knows that something is wrong with our math education, right? There are different opinions, right? People say that there should be higher standards. Schools will complain that there should be better infrastructure. We should reframe our curriculum. There should be in fact, not even in mathematics, right? These complaints come along in almost all subjects, right? And uh, there are a lot of opinions coming from different decision makers, schools managements, teachers, right? Academicians. But the only right thing that I found is students tell that math is stupid and boring. That's the only they are the ones who are actually right here, right? They find math is stupid and boring means it's actually right. They're very innocent people, innocent students, and if they find math boring, there is something wrong, right? So my question is, why should someone learn mathematics, right? We should start from there. Why should someone learn mathematics? Is it a tool to learn? I want to focus, I want to spend 5 minutes here actually, to put up some points which I found is very relevant. uh, there are different answers, right? uh, there are different answers which come to us, right? So for example, it's a tool for science and technology, right, to learn mathematics. And you probably teachers will answer, or someone will answer, that you will learn the applications in future. Right now all this trigonometry, integration, differentiation, calculus, all these functions will you will find it boring, but in future you will find applications. But sorry boss, right now I don't have an explanation to give to you, right? Ultimately what maths turns out to a normal student is a mindless manipulation of symbols. You'll give some x, y, square, exponents, logs, and you manipulate them to get some desired outcome or desired answer, right? This is what math has become. It has become a repetition and memorization of some disjoint technical facts. Okay, but what I find in mathematics is mathematics is essentially an art. We don't consider mathematics as an art normally, right? We consider painting or music or dance as an art, but we never consider mathematics as an art. That's what G.H. Hardy, a very famous mathematician, told. A mathematician is like a painter or a poet, is a maker of patterns. If his patterns are more permanent than theirs, it is because they are made with ideas. So mathematics is actually about finding uh, pattern, but it's an art actually. But in our schools, what we do is, the art of mathematics, we teach a lot of truths, right? This is the fact, this is the theorem, you have to learn this, you have to repeat the steps, you have to learn multiplication, you repeat the steps, to learn division, you repeat the steps, to learn differentiation, you repeat the steps, right? And uh, the art is not itself every time in the truth, right? The art is always in the explanation, the arguments it make, the perceptions it give, right? Actually we deny students to engage in this activity, where we just give them some facts, we just give them some truth, and we don't ask students to engage with this facts or truths. Maybe I'm sounding a little philosophical, but I'll come to some real examples where we can make sense of uh, mathematics actually, right? So students learn from teachers, teachers from their teachers, and we have never learned to appreciate, understand and appreciate mathematics as such, I would say. Okay, many time I would say I teach maths, but I would say I don't teach mathematics actually, I train mathematics, right? We don't give problems to students, we give exercises to students, right? And we train them to repeatedly go through certain steps so that they can come to some solution, right? We never give a new problem to students. So many people in chat now, they are commenting, right? They're commenting, math is used in everyday life, right? That's a that's why we should learn math, or we will use this in engineering. As an engineer I use mathematics everywhere. But if you go to the modern gadget, right, or applications, you have math lab, you have wolfram alpha, all these things, geogebra, and we don't actually have to learn all these techniques, right? The computer will do it for you. Or if you see carpenters, are carpenters actually using trigonometry? Are we using trigonometry uh, to measure the height of Qutub Minar, right? How many adults know how to do fractions multiplication or fractions addition itself, right? Uh, so I would say learning something is not just for practical purpose. Also, I completely agree that mathematics makes a lot of sense in the practical life, especially when you become an engineer or a scientist. But it's not just because of that we should learn something, right? We should not learn something only because of the practical purpose. We can understand the world around us in a more deeper, sound, meaningful way. And there are a lot of other reasons we do things, right? Why do we do music? Why do we do uh, there are professional musicians for sure, but do everyone enjoy music, right? Are we wasting our time on music or dance? No, right? We find it satisfactory, right? We goes in a fantasy world, and we find it satisfactory to ourselves, and that should be as an art, mathematics. That should be a good enough reason to learn mathematics actually. Okay, so in our schools, right, in an attempt to make math interesting and relevant to students life, right, we give them certain questions, right? For example, if you know, we will tell them, right, if you know algebra, you can figure out how old Raj is. If you know that he is 2 years older than twice her age 7 years ago. We give such stupid questions to replicate in practical life. The questions will make sense, but that's not that you're not learning mathematics to find out how old Maria or Raj was, and you're given an information that 2 years after 2 years she will be twice the age what she is now, right? This is not the way of learning. This is not why you learn mathematics, right? And if you find, right, if you find algebra, it's about numbers and symmetry. It's not just about having some practical applications. More than practical applications, we can appreciate numbers and symmetry with it, right? And uh, as I told, art should be taught by artists. So similarly, mathematics, every mathematics teacher, in my opinion, should be an artist. It doesn't mean that you have to be a professional mathematician, but at least we should be able to give an appreciation of what mathematical facts are. So I'll go to some practical examples I find interesting. I'll share them with you. There are a lot I can share, but I'll stick to two or three. Okay. uh, how do you define a cat? So we are all about definitions, right? In mathematics or in our educational system. uh, how do you define a cat? So a cat can be defined in very different ways, right? uh, from a caveman definition, it's a furry animal with claw teeth, a tail, and four legs that purrs when it's happy and hisses when it's angry, right? Or um, in Wikipedia, I just copied it from Wikipedia. The cat, which is called the Felis catus, is a domestic species of a small carnivorous mammal. If you go to a modern biologist, he will tell that cats are animals sharing a DNA of ACATATA, whatever pattern it is. This, whatever animals having this following DNA pattern, that's called a cat. So you can define a cat in different ways, right? But if you go to your school and tell a kid who has never seen a cat in his life that a cat is an animal sharing the following DNA, like this blah 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 blah, what is the concept he's getting about a cat, right? So you see the problem, right? We always start with complex things. So we know what is a cat, children have known what a cat is. So there are different ways of explaining cat. Or you can just see, touch, and feel a cat. That's a way of knowing the cat, right? Even if someone who is blind, right, who is differently able, they can also understand what a cat is if they feel it, if they hear it, right? So there are different ways to define a cat. So similarly, I will give a definition, some definitions of a certain thing in mathematics, right? You can comment what that is. Okay. uh, I'll start with the simplest of the definitions: a shape that gets most area for least parameter, right? A shape that gets most area for least parameter. This is the definition for something. I will give you another definition for the same thing: the shape whose tangent line is always perpendicular to the position vector. That's more a physical way of representing that same thing. The shape whose tangent line is always perpendicular to position vector. Another definition of the same thing, right? The same shape I'm defining about. The points, someone is telling regular shape. No, what is that regular shape? That's what I'm asking. The points in the equation are sine t, are cos t for all t. This is another definition of the same thing I'm talking about. Another fourth definition: all points in a plane equidistant from a given point. All points, this is more like you might find for sure in this definition, right? It's not a triangle, it's a circle, right? Thanks a lot, many people have answered that. All points in a plane equidistant from a given point from its center, right? So these are all the ways to define a circle. But do you think such definitions make sense to, of course they have to, we can explain in all these ways, but if you put this definition in front of someone who doesn't know what a circle is, what is he going to make out of it, right? So uh, circle, it's what is it, circle is nothing but something round, right? That's how kids have seen circle. So then we can explain, right? All these points are equidistant from the center, and then it has the most area for a least parameter for because of this property. And if you learn trigonometry, then this is r sine t, r cos t, these are the coordinates, right? And all the tangents will be always perpendicular to the radius. We can learn of all those things, but all these are not the central idea, right? The central idea is that the circle is something round. That's the central idea. And if we lack that, all these things are jargons. It doesn't make any sense, right? So I just uh, took a simple example because see, everyone knows what a circle is and we don't have to define it like that. But there are certain things in mathematics that we learn like this. For example, one of the things which I found very uh, uh, like very absurd, right, in my school was complex numbers. See, why do we need complex numbers here, right? As if real numbers are not enough, right? We already have a lot of things to learn in real numbers, but in complex numbers, now you have a square root of -1. uh, what is the practical purpose? It's an imaginary number. Why do you learn something imaginary? What is the purpose of that, right? And then someone, your teacher will tell you, or someone will tell you that it's used in advanced physics. Trust us, you just wait until college. Or someone will tell you that it's a mathematical abstraction, and the equations work out. Since the equations work out, just deal with it. You just learn it. You don't question us, right? So why do we actually learn complex number? That's some question which have actually baffled me from my schools, right? But uh, but when I went to college, right, when I went for to do my electrical engineering in IIT Madras, then I found that the whole idea of electrical engineering, the whole mathematics of electrical engineering is based on complex numbers. It's everything is built on complex system of numbers, and it's very helpful to learn complex numbers. But possibly, right, that my teachers didn't have an idea to explain me about that. And of course it may not make sense to explain me about it at that point of age, as they will tell, right? It's an advanced physics concept or engineering concept. You just wait until it get to college. But there are still things which we can make out of complex numbers, and that's what I'm trying to explain here. So I'll ask you, what does 3 minus 4 means? 3 minus 4 is -1, right? Does negative numbers, are they also theoretical just like complex numbers? Does that mean anything? So trust me, till 1700s, right, negative numbers didn't mean anything, and it was actually in the outskirts of mathematics, right? They were only theoretical. Then we found it useful was it's uh, it's actually useful to identify depths, right? 3 minus 4, which means -1, which just means that you have to give back 1, right, to calculate your depths, to keep your accounts. Negative numbers are really useful, that we actually started using from 17th century and 18th century onwards very extensively. We have used it before, right? But in the for example, you can see a lot of such things in mathematics, right? Why do we have like something like 2.5 or 2.3? uh, it, for ancient people, it didn't make any sense. You either have 2 or you either have 3. You shouldn't have 2.9 or 2.1 or 2.3, right? And only the Indians discovered 0, right? In the Greek system, there was no 0. They didn't find any meaning to 0 at all. But now we know how useful 0 is, right? uh, Similarly, there are certain things, right, that complex numbers also, we can try to make sense of complex numbers also, right? uh, so uh, People find out the usefulness of certain things, right, as we move forward. We can't tell that negative numbers are not useful, or 0 is not useful, or decimals are not useful. Similarly, we cannot just tell that complex numbers are also not useful, and even if it's useful at a later point of time, there is no meaning to that, right? We can't tell that to students. So what is actually I'm just trying to give you a visual understanding of complex number. I don't know whether you'll find it complex or not, but I'll just try my best. So if you tell that x equal to minus 3, right, what does it mean? It means x equal to 1 into minus 3. That means you're just scaling up the number by minus 3, right? You're just multiplication means you are just scaling up uh, numbers, right? uh, but then what does x square equal to minus 1 means? That's what our problem is, right? That's what x square is equal to minus 1 means. X equal to square root of minus 1, which we call it as an I in mathematics, right? So x square equal to minus 1 means 1 into x square equal to minus 1. I hope you agree to that. And we can't multiply by a positive twice because the result stays positive, and we can't multiply by a negative twice, right? If x is a positive number, you can't multiply it twice because the result will be positive, but we are getting a negative number, which is minus 1. If x is negative also, negative into negative is positive, so the result will be back to positive. So x in a real number doesn't make any sense, right? So but what we are actually doing by multiplying, if you see, by multiplying 1 with minus 1, 1 with x square and turning into minus 1, you are actually taking 1 from here and you are rotating it and bringing it to minus 1, right? So you're actually rotating this number. So I'm not telling that you should tell all the applications of complex number, what is it going to teach in electrical engineering, etc., but at least this we can do, right? What is it actually doing? It is taking 1 and it is rotating it to minus 1. So all the multiplication is about scaling, right? It's about shifting numbers, addition about shifting numbers, but complex numbers is about rotation of numbers. So if you're multiplying something with uh, I, if you're multiplying something with I, you're actually bringing 1 to I, which means you are rotating a number by 90 degree. If you're rotating by minus I, you are actually if you're rotating by minus 90 degree, right? So I or minus I, right, these are what numbers become when they're rotated. So that's what the actual visual meaning of complex numbers are, right? So this is what it becomes when the numbers are rotated. So multiplication by I means you are rotating a number by 90 degree. Multiplication by minus I means you're rotating by 90 degrees clockwise, uh, right? And that actually proves that numbers are two dimensional. Right now you have learned about real numbers which are on a single number line. Now you're learning about two dimensional numbers. That's what complex numbers are actually about, and that's what the application of it is in electrical engineering. It's not because some imaginary numbers comes up in uh, electrical engineering, right? It's because of this rotation we use this. So this is the idea where we are making use of complex numbers. So at least we should make give this sense to students, right? Learn through analogies, right? So for example, what does 3 minus 4 mean? Similarly, we have the question, what does square root of minus 1 means? It's both are strange questions in its own terms, because 3 minus 4, how can you have less than 0 something, right? You always have one orange or two orange or three orange. Then we try to make sense out of it, saying that yeah, this is the debt, I have to give back something, right? Similarly, complex numbers, how can you take the square root of something less than 0? Then we identify that it's actually the rotation we are doing. Negative numbers were considered absurd till 1700s. Till today, complex numbers are considered absurd, right? So there are a lot of uh, things, right? I just put together a table for that, right? Similarly, if you come to calculus, right, we talked about circles and complex numbers. Calculus is a branch of mathematics we defined as that deals with limits and differentiation and integration of functions of one or more variables. But this is not at all useful for a beginner. For them, we do integral x raised to n dx is x raised to n plus 1 by n plus 1. It's just some abstract symbol manipulation. But just like what we can find some analogies, right? Just like arithmetic is about manipulating numbers, and algebra is about finding pattern between numbers. For example, a square plus b square equal to c square, we know that is a Pythagoras theorem for a right angle triangle. And if we know a and b, then we can find out c. So calculus is similarly finding patterns between equations, just like algebra is about finding patterns about numbers. You can see how, like, the circumference of a circle is 2 pi r, the area is pi r square, the volume is 4 by 3 of a sphere is 4 by 3 pi r cube, right? So you can, the surface area of a sphere is 4 pi r. So all these things, you find the relation between pi and r, and calculus is actually finding the relation between all these things, right? So uh, a good way of teaching students is finding analogies between whatever they have learned before. Just like complex numbers, uh, you can make an example of negative numbers. So similarly in calculus, you can take an example of algebra, and we can actually map it to the real life scenarios, right? How does an equation grow and shrink? How does something accumulate over time? When does it reach its, when does some graph reach its highest point or lowest point? And we heat, motion, our population, temperature, everything, we use calculus to calculate them, right? So these are certain practical applications we have in calculus. And uh, and uh, uh, see, this is the thing, in my personal opinion, that we have to do. So what can we do right in our mathematics, right? So what all concepts we learn, right? We should try to find a central theme of a math concept, right? Whether it's primary grade or secondary grade or higher secondary grade. Why that idea was first used. See, why do you want to count something, right? Assume that you are in a restaurant and three people are sitting and they all order one biryani each, right? Biryani is a very popular dish at my side of the country, right? Now the waiter will he tell one biryani, one biryani, one biryani, or he'll tell three biryani? That's where the math began, right? We have to count something, right? And now you have to add something. So repeated addition leads to goes to multiplication, right? And there are fractions, there are real numbers, there are irrational numbers, right? So find the central theme of whatever math concept that we are teaching. We should look at the history to find out where it all started. See, calculus, why did calculus start? Newton discovered calculus so that his normal algebra was not enough to explain certain physics to him. So he started calculus. Why this idea was first used? What was the discoverer doing? And start from a definition that makes sense, actually, right? Don't give theorems that doesn't make any sense. Start from your intuitions, what makes sense to students very easily. Then uh, then you can explain the properties or facts using the theme that you have got, and explore other related themes, other properties, etc. And another good thing is a visual interpretation or feel things. So I told you, right? I work on a startup uh, where we work on STEM education. So what we actually do is we actually make sure students from first grade to 10th grade, right? We normally deal with students from first grade to 10th grade. So what we do is we give experiential education to them. Whatever science concepts you learn, whatever math concepts we learn, I'll come to that in my last point for sure. So math, actually, you can, it's more, math is not about some textbook and notebook and you write down, you blabber some equations, right? For example, this is some mathematics kit which I make, right? Which we make. We have a lot of things here. If you see, there are certain shapes made, and a lot of shapes made which children can play around. Certain other things, and there will be some graph papers. Sorry, 1 minute. I'm hearing some noise, Karthik.
I think it should be fine. You were quite audible, actually.
Uh,
I think it's fine.
just give me 1 minute. I'm having some.
Sure, sure.
Uh,
I think Ajmal is facing some connectivity issues, so he's just gonna be joining back. and then we'll be taking your questions. But meanwhile, I'll share the link for the feedback form in the chat section. So you could go there and fill that in, and it's going to be open till 9 p.m. today. So you could fill that in before fill the form before that. So we'll share the link, feedback link for the session in the chat, in the live chat section. I think Ajmal is just joined back. So
Hey, sorry, I think I lost my. I started hearing some noise. I don't know why.
sure. Not a problem. I think it's audible. I mean, you're clear now.
Yeah, thanks.
I think we should share the screen again.
Yeah,
Sure.
yeah, I'm sharing my
Yeah.
screen.
Yeah.
Um, so I was explaining. So what we can actually learn mathematics through doing things also. Uh, so here we give some what we do right in our startup. We give some activities to students. We have some activity sheets. So which is actually mapped to curriculum. We prepare some 20-30 activities mapped to each classes, and actually we give that to students, and they can work out on their own. They can play with shapes, and and we give actual learning outcomes. And what do you actually learn from this? How do you make sense out of these things? You can actually feel things and do mathematics also. There are as math teachers, many of you will know that for sure, right? And actually always start with a question in your classrooms, right? Not any repetition of steps, right? Actually our curriculum mandates us to do this, all the uh, so actually sorry, many times we give these repetitive steps, right? It's okay for students to make mistakes. It's okay for them to they ask questions, and we can actually give them puzzles to them, right? We know that children love solving Rubik's cube. I have always wondered, I don't know how to solve a Rubik's cube, right? But people who are one third of my age, who are 7, 8, 9, they solve Rubik's cube. They find it very interesting. They find the algorithm how to solve that, right? And the same person, they will complain that they are not good in mathematics, right? Or they hate mathematics. Why is it that? It's not because mathematics is not relevant or mathematics is not interesting, but we are set in our curriculum, we are set in a way that it's not interesting to them, right? And the most important thing which I felt even in my students life, it we should give time to students. We should give students time to struggle, give them time to learn mathematics, right? To solve problems, give them very uh, intuitive things without teaching them any theorems or as such. uh, but you can give them some perfect some problems, right, that you can solve over 2 days, 3 days, 4 days, right? In fact, one of the best things I liked about IAS is open book exams, right? You just don't have to write certain exams in 2 hours or 3 hours. You can have your book open, you can take 1 day or 2 day and you can solve it. So that's what real problems are. It's not, I'm not talking about the exercises in our max textbooks, but some real life problems we can give them, some interesting problems we can give them and ask them to solve that, right? Let them take their time. And one of the most important need of the time is an integrated STEM curriculum, right? STEM stands for science, technology, engineering and mathematics, as you all know. And we always learn these as disjoint things, right? Science is in a different textbook, and there is physics, chemistry, biology, then there is mathematics. Even though we are in a very technologically advanced world, we never learn technology or engineering in schools, or we learn very small amount of them. And actually these four things are binded together in a very very good way in the real world, right? All the real life applications you find when you put all these things together, right? So that's why as a kid, as I told you, I hated physics and maths because I couldn't find any correlation between them, because there was no mathematics taught which was actually relevant for my whatever physics I learned in my school classes, right? So to make purpose out of our education, we have to have an integrated curriculum for STEM. For science and maths should come together. Similarly, technology and at least a smaller level of engineering subjects we should teach in our mathematics. So I'm not telling us teachers you should teach them engineering. That's a this should go to the academicians, and I think our new education policy has suggestions with regard to this. But what I'm actually telling is, we can the simplest thing is we can put some central theme in any math concept, right? We can put some historical context on why we should study this, where this idea was first used. We can tell them that the pi is also known as Archimedes constant, and it was from the circumference by diameter we got the value of pi, and why it was important in history. The e which is used as a natural logarithm base, why does it mean? E means the growth rate. We can tell them that historically how does e come about, right? Instead of just teaching them that, yeah, there is a irrational number called e and its value is some 2.17 blah 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 blah, right? Or the value of pi, or as I told, complex number, there is something imaginary and you learn it in future. Instead of telling that, we can actually make some sense out of it, right? We can tell that it's the rotation of the numbers that we are actually uh, doing with it, right? And give our students some time to struggle with. I know it's hard with whatever curriculum we have, but it's the best thing for our students to learn mathematics, and that's what I think. uh, I wish I could have put more examples with you, but I think because of the time considerations, I shortened it. I had certain examples of radians and the E, etc. So, but probably some other times we'll revisit that. These are the hands-on boxes that we make, and thanks to Iqbal, one of my seniors in IIT, who is a max teacher, and these are certain books which helped me to have my math understanding better, math better explained by Kalidasa. There is a website called betterexplained.com. There is a book called Mathematician's Lament by Paul Lockhart, and there is a wonderful TED talk, Five Principles of Extraordinary Math Teaching by Dan Fingal. These all things help me in giving this presentation to you. And thanks for listening. If you want to talk to more on anything to me, I think you can have my number. You can mail me, or to know what work I do in STEM education, you can always visit our website, elanlearninglabs.com. Okay. uh, we partner with a lot of schools and to making education better, the experiential education, not just math, even the science, technology, integrating a STEM curriculum to schools. We work on that. Okay, so thanks a lot for listening. I think I overshot the time by some 3 or 4 minutes. Sorry for that, Karthik, and
No,
sorry
no,
for the
no.
technical problem.
Absolutely.
Uh, yeah, if we have any questions, and I don't know if I can
Sure.
answer questions, but I can actually have my opinions, right? These are all my
Sure.
thoughts and opinions. It's not like some facts that
Sure.
I'm giving to you. Okay,
Oh,
thanks a lot.
absolutely, absolutely, absolutely. I mean, yes, there are a few comments, and first of all, thanks a lot for the session, Ajmal. Really, really informative. Bunch of comments where people said that they have a set of concrete ideas which they can use in their classroom. So thanks a lot for that. And of course, we had a couple of teachers inquiring about the shapes that you showed, and of course, teachers, as Ajmal was saying, Ajmal has this organization called Elan Learning Labs, and we'll also put out a link for a link in our description, and you can go there and check out the solutions for yourself. uh, so I think I'm just going to pin some of the comments. And Aisha Mahmood Siddiqui, Aisha ma'am is saying we should always give our students voice, choice ownership, rather than asking them to know only the facts. This develops a tendency to inquire more about something. When they inquire, they become curious. I mean, absolutely agree with the sentiment, and Ajmal, would love to get your thoughts on that as well.
Absolutely. I think that's what. See, we have standardized tests. We have a standard curriculum. Probably that's good for masses. Uh, but I really think that's not the right way to do. Right. It At least for mathematics teachers, we should have some personalized education. Some different learning paths should be carved out. I know it's difficult. It's against the system, and may not be we may not be able to do it in every school or every place, but we should try to make that change, at least in some way possible by us, right? And as Aisha mom told, uh, of course, right, we should give more ownership to students. Let them see all these discoveries or inventions about mathematics, right? They were not, see, when did we start teaching mathematics in classrooms? I think it's in 18th century or 19th century. To create the workforce we needed, we started all these things in the background of industrial revolution. uh, how did math evolve, or any subject as such evolve in last 20 centuries, or in last millennium, right? No one taught, I don't know if someone taught Isaac Newton in any schools about maths. I don't know for sure. But of course they were curious, and they were curious because they had questions. It was not some facts given to them, right? Of course, agree to you, ma'am, complete. It's very precisely you put together what I have tried to convey. Thanks for that.
Sure. Absolutely. And Miss Rajni Radhakrishnan has a question, and maybe not exactly new alley because this is primary school, but we'll still see, what you think about it. Rajni ma'am says primary students are guided by parents after school, and the methods differ. I think the methods used by parents differ, which could create a confusion in the child, and they may lose interest and they find it difficult to cope up. How do we handle this? So she's referring to a situation when the child goes back to home after school and parents teach the children, and the methods that they could use differ. So how do we tackle that problem?
uh, that's a hard thing to I don't know, that's a hard to answer for me, as you told. But uh, see, even at home, right? Not even at home, even at school, I would say many of the students, right, they don't get the right ideas, I would say, right? We always start with the most complex things, right? The most complex definitions, right? There should be an intuitive way to learn things, right? There should be some we can start with some puzzles or some questions, or as I told about whatever concepts we learn, right? It should make some sense to them, right? It should not be about theorems. Now I don't know how much students learn mathematics in with their parents, but mostly it's in schools, right? So I would say mostly we have to correct in our schools, in our school curriculum, the way we teach, rather than worrying about what happens when they go home. But as you told, the parents, right, they are very obsessed with exams, grades, and all those things. As a startup, right? When I give these kids to students, the uh, the parents will ask me which exam my child will qualify, how much marks will he earn with this, to
Sure,
which college
sure,
will he get admission to.
sure,
That's the mentality of our parents, and that should absolutely change. I don't know how to change that. Only maybe the whole system should change, right? We are so
sure,
much worried about what grades we achieve, and we don't worry about the quality of education we get, the holistic way of education, right? We are always
sure.
worrying about the outcome, which scholarship they will gain, which see, kids have actually become a matter of pride for their students, to boast about their achievements, etc. Instead, we should be spending more time on, in fact, these sessions, right? These are the best things to do. Now teachers, I have shared my thoughts with you, you have shared my thoughts with me. The similar thought sharing should happen with the parent community for sure. I absolutely agree with Rajni madam that there is a big gap there, big hole there, and this thought sharing should happen. And the whole system should change for that. I don't know how, maybe individually we can make some differences, but the whole system is what which we should change.
Sure. Absolutely. And Sai Ramakrishna sir has a comment which echoes with the the sentiment of the whole session, and he says that he uses recreational activities, including puzzles and all, to make his math classes more interesting. Anjali T has a question, and Anjali is asking, can you give examples of how STEM education makes math interesting?
Okay, that's a very good question, and that's something I deal with. So, uh, for example, so this is a phone. This is an iPhone, right? And this has some 7 billion chips in it, or 8 billion. Sorry, 8 billion transistors in it, right? How does it work? Right? Any of our students know how does it work? Of course, my 1.5-year-old child kid, he knows how to stream YouTube, and he knows how to change between his nursery rhymes and songs. But if I ask a 10th grade student in a world which is like exponentially bursting out of technological development, if they know how this thing actually work, they will handle this superbly than us, right? They will better than me and you. They will go through, they know every functions, right? We can put a lock to them, but they don't know how this thing actually works, right? And there comes actually the transistors where we switch on and switch off the transistors, right? This transistors which are actually coded in binary numbers, right? That's a simple explanation of how you do it. If there's a current going through transistor, it's one. If a current is not going through transistor, it's zero. That's the physics put into mathematics. And there is that's where the whole binary system of numbers, not the decimal system of numbers, come useful in a chip. Where as a person designing chips, I know that that's very useful there, right? So that's how you should connect things, right? You should connect the transistors to mathematics, the number systems we have. That's one simple example I can put forward to you. And then you can, and that's how I told you, right? On this central theme, you can develop on the properties and why we do things, right? uh, so that's one example that I can very easily think of from an electronics engineer's point of view.
Sure. And again, there's another comment. Korivi Srinivas Rao sir has a comment and says, of course, one of the TPO winners from year one in 2015. I still remember. And sir is saying, mathematics is the study of environment in itself from which students can learn. And the only thing is, we need to teach students how to extract information from the environment, and they learn. So that's a very pertinent comment, sir. And and Salman sir has another comment, and he says, in his opinion, to remove math phobia, we can start math talk, and we can have children involved in it, involved in everything. So, absolutely agree with that. Um, I'm just looking for some questions, and yeah, this is something which Ashok Kumar Gampasar is asking, how can students practice math at home if parents are not capable of teaching math properly? So that's a question that Ashok Kumar sir has. Would you want to take that
uh,
question?
yeah, sure. In my opinion, see, my whole point is we shouldn't be able to we shouldn't be practicing maths, right? Always, it's not about practicing maths. So practicing maths, you can have the arithmetic fundamentals stronger and all those things, but all those things you can do with a calculator or a computer too. Probably that will help you to crack some entrance exams for sure. So but that's not actually we are looking in math education, right? To do your calculations faster, that's not the aim of mathematics, right? Of course, see, for everything we need to practice. Even if you want to become a professional football player, you have to go through certain steps, boring repetitive stuff that you have to do. That's part of that, but that's not exactly the aim of mathematics, right? Not to practice things. So the whole idea I wanted to put together through this small session is, right, mathematics is not about practicing certain things and repeating certain things and doing some exercises, right? It's about making sense, a deeper, sounder understanding of the world around us. Just like I think Srinivas sir just told that, right? It's about even if something doesn't have a practical purpose, it's about going to an imaginary world and fantasizing about certain things, right? Which has no limits. Mathematics absolutely sets no limits. You can draw whatever you want in your mind, and you can try to come up with a problem or solution to that, or you can explore things, right? That's what mathematics is about. So practicing is one part of that. My opinion, you don't have to worry too much about that. Once people are actually interested in math, they will do that anyway. They will not need any parents help or even teachers will be facilitators, right? So you don't have to start solving problems to them. So that's a whole different approach, in my opinion, that we should have.
Sure. And we'll just take a last question. We have a minute left. So Girija ma'am is asking, can you suggest names of some good math books on riddles and marvels with numbers? Just from your experience, what you may have liked.
So puzzle books, I don't know, I have went through some of them, but I don't remember names. Sorry for that. I haven't done any puzzles for some time now. uh,
Sure. Sure.
but yeah, sorry, I can't answer that. But the books
Sure.
I showed you, right, some couple of good books which I read recently, which actually shaped my ideas. I think I actually
Sure.
presented this. Mathematician's
Yes.
Lament is a complete game changer. It has very radical ideas which many of us, even I, do not agree to many of that. But that's a really an eye opener. That's something you can try reading, for example, right?
Sure.
uh,
Sure.
yeah,
And we'll
I
have a link to the
certain
Sure. No, no,
uh,
we'll have the link to the presentation, in the description after the session, so that Girija ma'am, you can come back and look at this slide specifically for this book, and you could take notes from here. So we'll do that. And yeah, so as a final comment, listening towards this, Madhavi ma'am is saying people who are having math phobia, students who are having math phobia will surely come out of it. Thanks a lot. Oh, absolutely, absolutely. So this session is going to be available on our YouTube channel. So this session is going to be here, and in case you liked it, please give us a thumbs up and share the video in your network and among with other teachers who you think could benefit from this from the session that we just had. Uh, I think that's it for now. We are all yeah we are running out of time. So thank you once again, Ajmal. Real wonderful to have you with us. Absolutely incredible. And all of us, I'm sure, have a set of concrete ideas that we can start implementing in our classrooms. And I mean, really practical tips, really practical insights. Thanks a lot for that. And we really look forward to having more sessions with you. I know you're a really busy man, but we'll definitely would love to have a few more sessions with you, and talking about something else. So thank you once again. Thank you once again for the for
thanks,
for the time.
thanks, Karthik.
And
Thanks for
so the feedback form, we we have shared that in the live chat section. So it's there. We're going to share that one final time. So please make sure that you fill it in by 9 p.m. today. We won't be able to help you in case you send mails to us saying that you missed the feedback form. So I'd request you to keep an eye on the link and fill it in right now, so that automatically tomorrow the acknowledgement records can be emailed to you tomorrow, by noon tomorrow. So please make sure that you fill that in. We're also going to pin that as a comment. The form is going to be active till 9, so please make sure that you take out time and fill the feedback form in, so that you can get the acknowledgement delivered to you via email in your inbox by noon tomorrow. Uh, Sure. Thank you, Benita, ma'am. Thanks a lot. Thank you, Nalini, ma'am. Thank you. Glad you liked the session. Thanks a lot. Thanks a lot. Have a great evening ahead. Thank you. We'll see you next week. And the next session is scheduled for 24th of September, which is next Thursday. And we are going to be talking about metacognition and why metacognition is important for remote learning. So exciting topic again. So we look forward to having all of you, for that session. So keep an eye on, emails from us, notifications from us on the different webinars that we're conducting, and register for them on my center. Encourage your friends and colleagues to register for these sessions and become a part of my center, so that they too can gain, on a professional front. So thank you, sir. Thanks a lot. Thanks a lot. Hope you have a great evening ahead. Thank you.